The problem is you do see a lot of antisocial people succeed. Loneliness is as big a risk factor for ill health and death.
We live inside our heads.
You go cold turkey, you go into withdrawal.
There is a lot of value in the stuff that we struggle with.
Better Thinking. Conversations with experts exploring all things psychology. Welcome back to Better Thinking. My name's Nesh Nikolic, and today I have the privilege of speaking with PhD candidate Lana Tikhomirov about advancements in AI-based technologies and their influence on human decision-making. We explore machine learning safety, biases, the application of AI to settings such as radiology, bioethics, and decision-making. Traditional research on human-computer interaction shows how challenging it can be to make effective decisions when combining two fundamentally different entities, humans and machines. Lana's work sits right in the middle of this emerging space, blending AI safety, cognitive science, and human factors research to help create AI technologies that are not only powerful but also complementary and safe. I really enjoyed speaking with Lana, and I'm excited to share this conversation with you. So let's jump straight in. Lana, I have to say big thank you for coming onto the program today. I'm so excited to be talking to you, as I do have a great passion in all things technology, along with all things psychology, but in particular, this space of AI, it's so fast moving. It seems like it's a profound step up from anything that we've seen before in history. So I'm really looking forward to talking to you about AI and how humans make decisions, and some of the research that is up and coming, and maybe what's out there already. So thank you.
Yeah, no worries. I'm looking forward to it as well.
How did you get into this space, if you don't mind me asking, to start off with?
Sure. Well, I look back on it now, and it's interesting that when I started, there was no ChatGPT. The idea of a large language model at all was this sort of thing in the background that some people were doing. And I still get surprised as to me actually making the decision to go at the right time into this was very serendipitous. So I did my honors in sort of classical cognitive psychology. That was focusing in human factors, which is, I guess, a division of cog-sci that people might not know, that really looks at how humans interact with automation, technologies, usually much simpler ones to what we know now. And I sort of had assumed that these human factors, people were everywhere. There would be cog-scis coming out of every single AI space, and that we'd all recognize just how important the human is in all these scenarios. But it turns out I was wrong. But I ended up just sort of happening to find a PhD role at the Institute for Machine Learning, where I am now, that wanted to sort of get the first real cog-sci student into the building to look at these sorts of interactions with AI. And I think I just took a risk, a bit of a jump, and just sort of fell into the whole field of AI and computer science. It's for the best. I was almost a little naive. I had no idea what I was doing, so I went in with no expectations, and yeah, it's definitely worked out for me. So,
you mind talking me through a little bit about that personal journey of going in very naive, knowing very little, and what's been your moments of kind of surprise, what's shocked you, what's been something you've gone, oh yeah, I thought that we'd be there. How have you experienced that?
Well, I think for most people familiar with psychology or social science, there is a very different, I think, attitude to science and humans that there are in technical fields. And I think anybody that works with engineers or anything similar to that sort of field understand that there are just different ways of conceptualizing problems, conceptualizing how to solve those problems. And I definitely wasn't used to the idea of a technical solution to social problems until I'd sort of entered that world. And I still see it to this day, but I think I'm a lot better at kind of understanding why people, choose a different way of doing things. Um, I think the biggest moment for me where I sort of realized that I was maybe not in a familiar territory was once that I had a colleague, a friend who was having a conversation about science with, and they were a computer science major and a very bright computer scientist, but couldn't understand really the difference between quantitative and qualitative. No matter how many times I emphasized, sort of started to realize, do I even understand what this means? I didn't know it was so difficult to conceptualize. But in reality, people just don't do qualitative research in computer science. They don't, understand some of the complexities of doing research on humans. So those little moments happen quite a lot sometimes.
It is an interesting space because uh, there is such an emphasis on the quantitative side, particularly,
Mhm.
just in science
Yeah,
in particular. There's still a strong leaning, and maybe for good reason as well. At the
yeah,
same time, there's very good reason for a qualitative approach as well, because there's so much uh, understanding and depth and appreciation that we as humans, would like to understand. And maybe that's some of the glue as well as to how we disseminate information. We try and make it a little bit more humanistic, so that we can
yeah.
adopt it. So I can see the value of both, but certainly in at least what it appears like, because I'm such a novice and I don't understand myself, but it
Mhm.
appears like there are some uh, uh, rigid ways, or not rigid, there are some fundamental ways in which, whether it's computer science works or whether it's AI, um, uh, it there must be some principles. At the same time, it seems to me so mystical. So I can see how both could potentially apply there.
Yeah, of course.
What is the research? Maybe we can start with what your research is, if you don't mind, and then kind of expand it out from there.
Sure. Well, I'm in an interdisciplinary space, so sometimes my response changes a little on who I'm talking to. But I think I would describe myself as a cognitive scientist that looks at human AI decision making. Um, I focus on medical decision making, largely because it's the most high stakes situation or scenario where you could need that understanding about how AI impacts decision making. Um, and I do work in bioethics. I have some colleagues and supervisors that work in bioethics. And I also focus on elements of human factors, as I described, and also machine learning safety, which is really a very technical field, looking at how models break, what sorts of biases they might rely on, and things like that. And I do I've worked with radiology and other medical sort of subspecialties, but I do consider myself to be quite general as well when I look at human AI decision making, especially when you look at what we can really extrapolate out from that specific scenario.
Hmm. It seems like there's an absolute abundance of areas that these large language models and
Mhm.
uh, uh, AI systems can be applied to, but certainly the medical side seems like it's the most obvious,
Mhm.
most pressing side, where the the value benefit is immediate. There's real genuine possibility of improving health outcomes, saving lives,
Yeah.
etc. And I know myself, uh, when I've had my skin checked,
Mhm.
I've specifically gone to a doctor that's used high definition photography against
Yeah.
their AI system. because I feel there's a comfort level that these systems are likely to see more than just the doctor alone. Having a doctor and this system interplay feels just far, far superior. And little things like, having your 25 photos taken and then them saying you've got, 642 moles on your body, and there are only 3 that need to be looked at. And I've got a high definition image here, and I can look at it, beyond even my my own little other instrument, and kind of looking at it, and it's giving it, factor result, a risk result, I suppose. But still having a human there to say, I want to eyeball it. I want to have a look at this. There's still comfort in that, because clearly he's a specialist that's been doing this forever and a day. I wanted to have a look. That's why I went to them.
Yeah, I take quite a similar approach nowadays, where I do sort of feel more comfortable with the idea that there is a background check, or there's an algorithm that's also trying to do the same task. So you might have that extra layer of security. But I mean, it's funny, I think that way, even though I really look at some of the dysfunctional ways the sort of duo or the unit of the doctor and the AI can sort of work. So yeah, I find it interesting to be confronted by my own beliefs sometimes in this work.
You mentioned that some of the work that you've come across is under, looking at machine learning safety, where there's, biases, how systems can break or produce incorrect results, or hallucinations, they're sometimes called. Can you talk about that a little bit? Where have you, where what's the literature saying? Where do we find it? How are we compensating around that? What are the protocols?
Yeah, I think that sometimes there's an idea, perhaps more in the past than now, but there's a conception that, and usually from people who aren't really quite understanding about certain elements of human behavior, people sort of saying, well, humans are biased, and so we need algorithms because they'll give us an unbiased look at something, or they'll do it in an unbiased way. Which is fundamentally just not the way it works. When we look at machine learning from a technical perspective, what is a bias? When we're really trying to define what that means, we're thinking of the sorts of biases that, I guess, in a human perspective, are making incorrect social deductions that are changing our behavior, maybe are feeding into stereotypes and the sort of the negative ones that we think about. But bias, I think the way that we really look at it in machine learning is that there are patterns that machines or algorithms see. What they are doing is going through data to find patterns to get a result, whatever that result is defined by whoever's making the algorithm. And it is, inevitable, really, that data holds so many biases and tendencies to reflect certain populations, certain ideas, certain decisions. It's really quite a complex, messy thing. And all the algorithms do is also find patterns that are sometimes also not representative, that can lead to harms, that can make shortcuts, and those shortcuts can be harmful. And so really, the way I look at it is that perhaps we're both biased in a certain sense, but I do think at least humans have the capacity to be reflective on themselves and perhaps to become aware of those biases. But with an algorithm, I mean, you can sort of train it out of it maybe, but most of the time, if a pattern works, it works. And why wouldn't it? From a logical perspective, like, of course, if a certain bias pattern helps get to a diagnosis quicker, then, of course.
And I can see that our whole training, not whole, let me rephrase that, so much repetition in our training goes towards correlations don't equal causation because
Yeah.
that's effectively saying this pattern does not go out and explain that pattern, but
Yeah.
they might coexist.
Yeah.
So, the classic one that I always think about is, seeing the pattern of crickets making noise does not mean that they are responsible for pushing the moon out into the night sky. Um,
Yeah.
but they are certainly occurring quite
Yeah.
commonly, depending on what region. Sometimes it might be, cicadas or something. Uh,
Yeah.
but being able to see that these systems are also trying to do something similar to what we are, um, and the importance of still going out and querying that rather
Mm.
than saying, look, Chat GPT or Grok or
Yeah.
Gemini or the many other number of systems. We've got to be careful not to go out and just blindly follow them.
No.
I know that some of them now, and look, I don't know anything about it. This part of the problem. We make our own assumption,
Mm.
and we make assumption from a little button. There's now a little button at the
Yeah.
bottom called like deep search or something. Uh, and what's interesting is it implies more security, that it's gone out and thought
Yeah.
more deeply about it. So therefore, it's more accurate. Um,
Right.
and it's quite funny because it also, air quotes, shows you it's thinking.
Yeah.
So it will go out and say, I'm looking this up and I found this, now I need to go out and understand what does that term actually mean. So I'm now searching over here and da 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 da. And it can take, I mean, I've done those sort of searches. They can take like 4, 5, even 10 minutes to
Mm.
produce something. Uh, but there's almost like a comfort in
Mm.
because it
Mm-hmm.
says, well, if the system's going out and doing this, it
Yeah.
must have more validity, right? It's thinking.
Yeah.
This is
Yeah.
great. Um,
Whatever thinking means.
and because it's telling me what it's thinking, not that you read it. There's no one who
Yeah.
goes out and reads it. I'm sure there's some tech people who do, but who goes out and reads it? That would be like like
No.
a short book to go out.
Yeah.
And then you'd have to actually follow up all the resources and sources as well and so
Yeah.
on. But it is fascinating that that bias starts to, at least if I observe myself, starts to occur. We just become, for lack of a better word, lazy. We lean
Yeah.
into comfort. It's just easy to say, yeah, it's correct because, Grok said it, ChatGPT, Google said it.
Yeah. It's amazing how much your own human perception can impact the use of these tools. And I feel like we do project a lot of our beliefs onto these algorithms.
Hmm. I think where it might have absolutely stunning capacity is to go out and find patterns that we are just simply not aware of so that we
Mhm.
can then investigate it.
Yeah.
Because it seems to me that the two interplay between, machine and human, if we come together, we can go out and say, maybe there's an insight that I can't see
Yeah.
because I can't see the pattern in big data.
Yeah.
You can
Certainly.
see the pattern, and then I need to explore it. Is it the crickets
Yeah.
that are taking the moon out into the sky, or is it the cicadas, or is it something else? And if you can
Yeah.
go out and highlight, 300 correlations, maybe one in those 300 will tell us a little bit more of the story.
Yeah. That's precisely how I tend to view it, as well as, um, this is a tool to be able to look at data in a way that we just physically can't as humans. And there is a distribution of skills or I guess expertise where, humans will have their expertise and specialty in one sort of cognitive area. And then, you go to the algorithm for the other side, which is to have, data and things like that be sort of narrowed down in ways that are useful to us and to our tasks.
Hmm. How does it work in a place like radiology? That seems like it's got some more defined boundaries or
Mm,
an easier place, at least on surface value. It looks that
yeah.
way. It's kind of like, oh yeah, that's an easy place to apply it.
Yeah.
Um,
Yeah.
how does it work in that sort of space? I kind of discussed it briefly about checking moles.
Yeah.
You
Yeah.
feed the machine, you know, 500 million pictures of moles, and you tell it which one has been, which one hasn't been, and
Yeah.
then gets a bit of a model together and starts explaining more things. How do we do it in radiology, or what's the current tech that you've observed?
Yeah, well, I think radiology was really the cornerstone, the first sort of application of AI in medicine where we realized maybe we can do something. I think that's certainly the beginning point, basically because we found this basically, it's called a convolutional neural net, which is sort of the original architecture for algorithms that look at images, that analyze images. Um, and we're starting to see that they could be trained on sort of a large corpus of imaging data and begin to get some pretty accurate results or diagnoses, if you will. Now, that process has been and still is one that requires many, many years of refining down these models with lots of radiologists themselves. You need extremely large amounts of data and you need lots of training. We've seen many algorithms from the earlier days that, said that they could detect pneumonia, but were actually looking at tokens in the corner of the images that the doctors had signed off as having pneumonia and things like that. So it's sort of it's not very simple to look at to sort of just get a model to find something. There, but it was sort of one of those ones where, we had the data and we started to have the architecture. And so that sort of just took off. And now I think it's in a place where we are having algorithms that are able to find a large variety of different pathologies and perhaps some that are more difficult to find for radiologists than others. And I think that's partly due to the fact that an algorithm can see the granularity, or I guess that real pixel level look at an image that a human just can't look in that depth. And so we're trying to utilize the ability to see patterns that aren't easy to see. And so that's sort of how radiology became, I guess, the cornerstone almost of AI in medicine. But I think it comes with a lot of tangents because there was sort of a big boom in like 2018 with deep learning, and suddenly every company and every, who, what, wherever wanted to adopt AI algorithms, and there was this huge uptake. And people like Jeffrey Hinton, who's one of the sort of, I guess, early researchers of AI, was making claims that radiologists would be extinct by the year 2020. And I still know many. So those sorts of that big uptake, that big spike, and then realizing, oh, actually, these don't really generalize well. They don't actually work that great, and then sort of crash back down. And then there was a long period of really thinking about how can we do this well? How can we test them well? How do we regulate it? And then where I come in is sort of looking at how do they change their decision making with it. But definitely a very interesting beginning area for AI, I think.
And in traditional radiology, is there usually additional data provided to the radiologist when they are looking at scans, for example?
Mm.
The age of the patient, I'm assuming, is fairly
Yeah.
would be, certainly data that's provided in terms of, gender, and
Yeah.
I assume there'd be an understanding as to why a particular scan is being applied, what they're specifically looking for, and maybe a
Yeah.
history of the patient. Like, how much data is usually given in radiology? And look, it's a broad question because but maybe you can talk to it a little bit.
Yeah. Yeah.
Apologies if I'm going a bit broad. And is the same is a same approach provided for the AI system, or where we're still trying to just give it images and go out and say, are you able to produce the same result purely on an image, so to speak?
Yeah, well, so radiologists do get, I guess, the my word escapes me at the moment, but basically the referral.
Sure.
They'll have a few sort of dot points of information of like patient exhibiting X symptoms, patient, age might be this. But on the whole, I wouldn't say it's as I guess deep as maybe a one-on-one GP session. They don't talk to the patient at any point or anything like that, really, except in maybe a few cases. So they are largely getting images, but the degree to which a radiologist might use sort of that sort of referral data and things like that can be highly individual. But so for many reasons, it does sort of make sense in a way to think that perhaps, radiologists can just look at images and just sort of know stuff. Surely an algorithm could do the same. And I'd say an algorithm is similar. They will largely be trained purely on images, but they are trained in a way that is entirely different to a radiologist. Radiologist is still a medical doctor. And one thing that I've done from my years of researching radiologists is look at their expertise and how it forms. And so to look at an image and really quickly just instinctively know there's something abnormal about this before they even know what or where or how, that's something called the GIST signal, which is basically this form of expertise that some expert radiologists have that makes them basically just really good at looking at images. And even apart from that, sometimes we find that people can be sort of expert searchers or expert radiologists, regardless of their subspecialty or how many years they train, and things like that. And so they are coming into these images with not only a whole background of medical education and I guess that sort of experience of looking at images over many, many years, but as human decision makers, the way that we've sort of described it in our work, they're what we call ecologically rational or sort of grounded. So they have bounds to what they believe to be plausible, what they know to be true, based on the fact that humans have a good understanding of context. Being somewhat limited in our processing power and the time that we have to make decisions, what we do is we become really good at using small amounts of information effectively. They can go on a scan and say, I'm not worried about all of this. I'm worried about this. I know about this. Whereas an algorithm, in a way, is trained in a much, much more simple way. It's through a process of what we would call a loss function, which basically means we're going to be giving an algorithm all these images, MRI images, and every time it gets worse at predicting a certain output, perhaps, let's say, a tumor, we're going to penalize it. And that's a loss algorithm. And until that loss reduces and reduces and reduces, we're going to keep training it. We're going to keep training it. It doesn't matter what it's relying on the image most of the time. It doesn't matter if it's not even actually looking at the tumor itself, but the texture around the tumor or something like that. It doesn't matter, so long as at the end it can reliably predict a tumor in, for example, a breast MRI. And sometimes that can lead to incredible results. But obviously that way of training, or at least the traditional way of training, as you can see, can sometimes leave some less than desirable results.
It's so complicated because it's such a good example of trying to infer a signal, sometimes specifically looking at the item versus, for example, looking at what surrounds the item. And pattern recognition is such a difficult thing. It's so blaringly obvious when you can do it on, something that's very granular. So something that's very, yeah, blind Freddy could, excuse the pun, but or the language there, but it's like anyone can see this versus there's this nuance that needs to be really understood, and that's really where medicine lies. It's not the obvious. It's really in the grey, and specialist understanding of at what threshold are we going to say signal detection is there versus
absolutely.
And that is just so difficult. And at the same time, look, I don't know, maybe you can kind of shed some light on it. It seems to me like either humans are not very good at explaining, or humans don't actually know how some of these models actually work. They ask the model to do something, but they don't know its reasoning. So they're not being either told that that's what it's looking for, or this is the pattern it's trying to find. It's almost like left to its own device to figure it out. And then we do this reinforcement learning of saying, yes, you got it right. No, you didn't. But I'm not really sure what you're doing, and as you mentioned, one of the funny ones is, if it's reading in the corner of the scan and it's saying, yes, we see demyelination because it's been written by all the actual doctors. Well, then you picked up on it, haven't you? Right? You're cheating because we haven't recognized that we're working with a machine that's going to pick up that pattern. But we're trying to go out and understand how you're coming to that conclusion. Is that something that we know? Is it still in this mystical space? Do the experts actually know this is what it's looking for and this is how it's come up with a conclusion? Or is it just or are we as blind? Are we blind to their pattern recognition process?
It's a great question, and it's also probably the most hot topic, which we would call explainable AI or explainability. And I guess the short answer is no, it's still a black box. And I tend to take any claims that there's suddenly an algorithm that can perfectly explain its sort of process with a big grain of salt. And to be honest, not many people do, because it's just a well-known fact that they're black box algorithms. The way that I look at it is really that we're making a trade-off, right? We're we want something that can look at an absolutely huge corpus of data and spend many, many days and a lot of compute to filter through that, and sort of create parameters and put different weights on certain pixels and then have nodes and different layers of those nodes. But the reality is that at the cost of that is that we're not going to be able to get that insight. It's such an unfathomable actual amount of data and parameters that, I mean, even from an image model all the way up to a large language model, which has trillions of parameters, it's not only not really possible, but it's also just not useful because it's so large and there's so much. And we can sort of like back propagate is the term, and sort of go back through those layers and, try to understand like what weightings we're giving to what. But the reason for that, they can't explain and we won't know. We can only make inferences from. And so I really make sure to really try to, I guess, address certain misconceptions about explainable AI, because explanation as this important thing to have, I think has only really come round in the era of AI, really, because we have research that shows that different experts, this is research from Cogsci, different experts, especially at the highest level of expert, are actually not very good at explaining their decisions. They're not good at explaining how they did something. It's, how did this, how did this athlete do this, or how did this doctor know to do this? It's like, oh well, I just kind of knew, just kind of did that. These are very intuitive, very quick sort of responses that don't always have the benefit of having this lovely set out sort of story of, well, I did this because of this and this because of this. And I think it's no different for AI, really, in that it would be great to, actually truly have explanation. But I think that it's also not necessarily going to give us the sorts of reliability or the sorts of things that we actually really need from AI models.
It's almost like trying to explain for those incredibly naturally good detectors who are able to find this kind of gist signal scenario. The explainability of that is impossible. They can explain it, but the reliability of the explanation is kind of useless. Because they're just going out and saying something just doesn't fit right. And interestingly, there would be many a time where they go, it doesn't fit right, and we still explore it and nothing was wrong. But it was sufficient enough to trigger something in them. They then went out and looked at it, and that wasn't an issue. But it was off enough for them to say, I don't like it. There's something like here. I'm not comfortable that we should. It warrants investigation. Right? When they do hit that one in X number, 7, 15, whatever it might be, and they figure something out that no one's been able to see for 18 months, we go and applaud them and go, this is the most incredible thing. At the same time, at some point, someone's going to find something and applaud them. It's so complicated. It's so complicated, but the explainability is still a black box is what I'm understanding, which probably makes sense because the moment we go out on and look at so many parameters, it becomes unexplainable because we have a capacity anyway. If a computer did say, oh, let me tell you, I looked at A, B, C, and D, but that alphabet goes for 4 million tokens, and then I put them up against these 3 million tokens, and then I, use these parameters that you guys told me is in the literature, etc. Like this just becomes absurd. This is just we're just talking theory again. Not applicable to another human. We don't have compute power like that. We have a gist. We don't know what that means, other than hey, here's someone who just, for whatever reason, picks up on some signal better than others. And it's probably not, I don't know, maybe you can tell me, but it's probably not like it's a 50% improvement. I'm assuming it's kind of like a marginal improvement. It's still significant, but I can't imagine it being just, light years ahead. The common radiologist is probably nailing most things phenomenally well.
So do you mean I guess the accuracy of the models?
My apologies. In terms of going against the super signal finder radiologist versus a regular radiologist. Obviously, we're trying to get AI to find something more reliable, less manpower, and hopefully better. The goal is always better. But even finding something equal and reducing manpower would be phenomenal.
I think at the moment they tend to perform at best sort of as good as a good radiologist, an expert radiologist. I wouldn't say they're necessarily always blowing them out the park. I think it's more the direction, right? There are certain diagnoses, there are certain pathologies that an AI will find easier than a doctor that do tend to fall through the cracks, perhaps. And then that's what sort of brings that, performing radiologist there. And then there's other things that perhaps doctors are just more in tune with, or they find it easier, or they know it's more important, and so they might sort of outperform on that level. But it's interesting because a lot of my work has sort of been about demystifying the idea of outperformance. There's a lot, again, I think this was more in its heyday, but a lot of papers that would talk about, well, my algorithm outperformed radiologists, and then there'd be so many under that narrative. And they're looking purely at AUC, on this number of images who had the high AUC. And then that's all well and good, I guess, if you're looking at the most simple form of AUC and you're not really going into any of the decision-making stuff. But we often find that, and one of the biggest problems in the medical AI field is people sort of take that as gospel, and then as soon as it gets all the way down to implementation, sometimes, for want of better words, shit really hits the fan. Right. And suddenly those studies are meaningless to us because, well, we put this algorithm out and, suddenly it's showing that it's not picking up on the most basic of thing, or, I don't understand this. This is becoming too complicated for me. I want to turn it off. I don't agree with these diagnoses. It's giving me too many things that I would never put on this report. All these different things that become so much more important than just the sheer outperformance. And so I think that in general, we can have AI that performs as well as a radiologist, or perhaps even more. But I would say that is the exception and not the rule.
Mm-hmm. With so much resource, and obviously this being an incredibly lucrative space when it's cracked, right? Assuming it's cracked. And it seems to me like it's going in that direction. It seems to me kind of like with self-driving, clearly we're not there. At the same time, clearly we're close.
Yeah.
And we don't know how close. So, the promise is always we're 2 years away, we're 2 years away. We've been 2 years away for, 15 years. But clearly the difference between models has vastly changed and great improvements. What do you see or envisage in a place like radiology specific, where the parameters are maybe a little bit tighter, maybe not? I mean, these are complicated because, as you say, when it tries to actually be applied, sometimes it's not really fit for purpose, and there's all the other stuff about the tools need to be intuitive for the human user as well. You can provide all the data under the sun and you just overwhelm the human being, and they're like, I just want a red or a green. Give me a red screen with a rationale of 7 points. That's where I want to be limited at, because my brain goes into panic mode afterwards. Or it might be the change model. But the question is what do you think it looks like, having seen the progress in your shoes, if I try and do sort of short term, like 10, and I think 10 years is short term for, if I said 100 years, then anyone's guess. We've probably got robots doing the whole damn lot. But where do you think, what does this look like potentially in 10 years' time? Will we have cracked the code?
Well, I consider a few things when I answer this question. The first one is, you'll hear any computer scientists usually complaining or talking about compute. There is an idea that better models equals bigger, better compute, more data. That's not always true. That's usually a way that we find big corporations can ask for huge, crazy amounts of compute and water and cooling power without having to justify much more than that. That's what I find. But so there is compute. It does take many, many days to process images, and even more if you're trying to make a hugely comprehensive, reliable model. These companies do have to use a lot of power. And so on the one hand, I'm very aware that the idea of having more efficient, faster compute, I'll go there, I'll say quantum power, that is something that would change the way that we process data and the way that our algorithms are. So if that were to happen, again, 10, 15 years from now, I would say that we would get a huge jump, not just in medicine, but in so many areas. But you'd certainly see the effects of that, I think. You'd be able to train more data, at least. You'd be able to do things quicker, more efficiently. The breadth of problems that you could answer would be so much wider. The mathematics you use, things like that, have vastly changed the game. But then on the second half to that, the other tangent, I think, is also just in data itself. Radiology, the machines that you use, MRI machines, things like that, they're not always bulletproof. We're always trying to improve on the quality of our images, on the resolution of our images. We can always have limitations based on those sorts of technologies. The image is sometimes as good as a scan, and the scan's as good as a machine, and things like that. But also just the images that you have. I think that data in itself is imperfect. I think that it holds a lot of, I guess, biases and different things like that. It can be noisy and messy. Sometimes there's just not enough of it for a certain problem. I think that we would need to have algorithms that can work a little smarter with the data rather than needing lots of it, if that makes sense. I think that's something that can set humans apart from algorithms, in the sense that I think we only need to see something once or twice to really learn and go, okay, I know this now. Whereas an algorithm would have to see it hundreds, thousands of times. And even then they might not. So I think that comes down to really the science of machine learning and continuing to get really theory building research out there about how to actually improve the real core components of a machine learning algorithm and the mathematics behind it. Stuff that's out of my depth. But I think that also, it can't just be data and compute in the end. There has to be smart algorithms. So those two things, if I were to try to put a time stamp on that, I think we could see that in the next 20 years, maybe even the next 10. I don't think it would take 100 years. But it's, anybody's guess, again with quantum, like, will it even work? We don't know. So.
Yeah. But one of I suppose the bottleneck around compute, which is then obviously a bottleneck around energy, is really trying to say, based on today's training cycle, on today's algorithms, which are fairly hungry for compute, fairly therefore hungry for energy, and therefore, the bottleneck of in actual fact the entire world trying to use these, in computers around the world. If that was released, then the iteration cycle would be shorter. So you could train a model and recognize, no, it's not producing what we thought it would produce. Now we can go into another training cycle. And then we go, okay, well, it's still not producing. And so the iteration cycle can become shorter and cheaper, and therefore advancement comes through that. So by virtue of adding more compute, which means adding more energy and supply chains for these damn things, because these are infinitely complex things. And it's so reliant on getting these supercomputers to talk to themselves, in terms of how many chips can chat with each other at any given time, how efficient they are, the infrastructure around them in terms of water cooling or air cooling. And also, as you say, every time an MRI machine or any other radiology scanning machine changes, we need to go out and apply an algorithm to that, because once again, it's looking at something new, potentially, right? Might not be looking at the same thing. So this is an ongoing space, and the question is, like, when do all the models come together, whether it's infrastructure, whether it's actual advancement in scanning, which we're continually forever doing, and then compute and energy. And like that $1 million question of, when does quantum computing arrive? that could potentially be like the fusion reactor.
Yeah.
It's a bit elusive at the moment,
Yeah.
but
Yeah.
but we can still see steps, incremental
Yeah.
steps moving forward. So maybe 20 years is a better way. And I can imagine there's probably even a time where we see it improve
Yeah.
and then it declines again, like it
Yeah.
plateaus,
That
right?
does tend to be
Up
the
and
way it goes.
yeah.
Yeah. Yeah, for sure.
What a fascinating space. I know we're getting a little bit short on time, but can you maybe talk a little bit about the bioethics
Yeah.
parts before we finish up?
Yeah, I'd love to. So I really came into bioethics kind of by accident in the sense that my supervisor has a colleague who's a bioethicist. She's now the AI lead at the Women's and Children's Hospital in Adelaide. She was at Sick Kids Hospital, Toronto. Her name's Melissa McCradden. And she is really, to me, like I think one of a kind of a bioethicist. So someone who is actually a trained ethicist, not the kind that, we're just putting ethics on the word as a label, but an ethicist who specializes in innovative technologies and AI algorithms in hospitals. And I think we all look at lenses when we look at problems. It's a very, very social science way of explaining something. We all look at it through a lens. But if you want to look as a disciplinary lens, cognitive science, I think, can be really quite analogous to ethics or bioethics in the sense that we might be looking at, is a decision good? Is this decision, with an AI made in a way that is optimal or beneficial? And then the other side, the ethical side, is this decision reasonable? Is this a good decision, or what makes a good decision? And those two, I think, interplay a lot and should, because ethics is a huge thing for AI and for innovative technologies generally. And so she's now one of my supervisors, and I work quite closely with her. And we do try to take that, I guess, that lens altogether. And I think that the question that I now ask is not just, is this algorithm good for decision making, for human decision making, but is it ethical to deploy this algorithm in this setting? And the questions that arise from that are so interesting. And there are ways to answer that and to investigate that using methods from bioethics, which is something I'm exploring. But it's a totally different ballgame to CogSci, and I think it really enriches that sort of side of decision making, or looking at it from that point of view. So we do some work with looking at youth's perceptions of medical AI, and investigating how do young people actually see, the future of AI in hospitals, and how do they feel about it, and looking at some of the perhaps hidden assumptions and biases and things like that. So that's one component. But the main component is actually something called the Canary Project, which is around the idea of something called the silent trial, or the translational trial, which is formed because randomized controlled trials are not commonplace in medical AI. It's actually quite astounding for how many years people were just putting algorithms straight into the doctor's hands without any form of pre-testing. And we recognize that, RCTs are the gold standard of testing in many ways. But they're sometimes also quite unachievable. Sometimes we're resource constrained, we're time constrained. So we need other ways to be able to validate algorithms to be safe and effective for going into care. And one of those ways is to test it silently. Basically, in the background, you'd have an algorithm running on all the same cases and patients that a doctor is looking at, but the doctor doesn't see that output. There'd be a separate team looking at that. And then after a period of months, you're able to look and see, how did the algorithm perform? Were there any subgroups that it performed worse on? Did it have any declines in performance, any spikes in performance? How did it flow with the architecture, the data flow? the infrastructure? What was the environmental impact of that algorithm? All these different questions. And so we're developing a framework to be able to hopefully have hospitals of many different capacities and resources to adequately test their algorithms and know, okay, now this is safe to be deployed, and here's all the things we need to keep mind of. And that is a question of bioethics, especially, but it also requires many different fields. So it's an interdisciplinary project.
Yeah, it's so fascinating that the importance of bioethics to almost act like a bit of a handbrake to say, before we do
Yeah.
anything, let's just be mindful. Let's be really
Yeah.
considered. You know,
Yeah.
we know AI is going to go into every field, period.
Yeah. Yeah.
We just say, how do we be really thoughtful rather than just injecting all of this stuff
Yeah.
willy-nilly? At the same time, the ethics around how do you balance the opportunity of uh, deploying something that will literally change outcomes.
Yeah.
And there
Absolutely.
are, you know, if the handbrake's too tight, there's a great missed opportunity. If the
Yeah.
handbrake's too loose, we can harm people.
Yeah.
And
Exactly.
sometimes these are all model driven as well. So we don't even know on that basis
Yeah.
to go and say if we deploy faster, we might go and harm, 1,000 people. But
Yeah.
based on that, we save 1 million, right?
Yeah. Yeah.
These are all models, and so we end up
Yeah.
taking theoretical inference from all of this.
Yeah.
But also, I love that. Did you call it the Canary Project, or
Canary, like the
yeah,
canary in the coal mine.
really trying to go out and say, well, let's run this as almost like a double blind. Doc, you
Yeah.
do what you're doing,
Yep.
and I like the idea as well of providing it for a length of time, not only for the need for data, but obviously when we are being watched, if we know we're going to go up against AI, we try harder.
Yeah,
And
exactly.
in
Yeah.
regular practice, we might not do that. The regular human
Yep.
has that as a bias to contend with as
Yeah. Yep.
so it's very complicated. Look, there's nothing wrong with trying to get AI to go up against, clinicians that are trying their hardest. But at the same time,
Yeah.
sometimes trying harder gives a poorer result. Like even that
Yeah.
can happen too.
Yeah.
Probably unlikely, but it can. I mean that's why
Yeah.
the research. But yeah,
Yeah.
sounds fascinating. Sounds like all of these things need to be considered, and it's very complicated. But
It is.
AITR, I mean, I've watched it in my practice. We purely use
Yeah.
it for note taking.
Yeah. Of
And in
course.
the space of a 6-month period, and maybe not even a full 6 months, it's gone from excellent but clunky to
Yep.
excellent and sometimes absolutely phenomenally amazing.
Mm.
But every day, every client, every situation is a roll of the dice. You just don't know.
Yeah.
Um,
Scribes are just that, like, talk about something that just came onto the scene. It's just changed the way I even do my research. I find like I think that scribes are really one to watch, I think.
and also us as humans, well, I'd like to think I'm high in conscientiousness. I'm quite diligent, and so I
Mm.
force myself to read the notes in its entirety and
Yeah.
make changes
Yeah.
and work harder because I know there's a voice in my brain saying, "Yeah, you kind of got it all right, so the summary must be right as well." And
Yeah.
because you just get lazy,
Very
like I've got
convenient.
my next client waiting, and I physically force myself or cognitively force myself to say,
Yeah.
do not lapse. You don't know what it's written. This is your
Yeah.
religion. And yeah, they've got their little thing which says make sure it's correct, but we're human. So
Little
if they
fine print.
actually, yeah, we will
Yeah.
break it.
Yeah.
I will break it by
Precisely.
the way I use it.
Mm.
And so it's important because there are errors all the way through it. Sometimes it nails it, but you get comfort with that. And,
Yeah.
once again, you become
Absolutely.
blind. It's not right.
Yeah. Yeah, exactly. I think that I mean, it is so hard. It's that idea that, you're learning from feedback, right? And like, this time, I've read this, this seems correct. This lines up with what I believe I, want it to say. And then, okay, so then you're feeling confident and then, something happens. And then because of that confidence, maybe you let something lapse. And then, there's so many elements to look at from a cog sci perspective and all those sorts of things. I think that we will see that I think they will improve over the years. I think they need to improve. I think, we're not there yet, but I certainly know the importance of scribes to clinicians. I know how much they are excited by the idea. And so there's huge incentive to research that and to try to find those sorts of best practice guidelines beyond just, make sure you check it, hope for the best, and don't sue me so it goes wrong.
And learning how to be a clinician with a scribe, because
Mm,
uh, I'd often understand my client through putting the words down.
yeah,
And the part of the story that I would write is different to the part of the story that the scribe writes. And I'm now
absolutely.
trying to
Yeah,
understand, how do I remember my client? And those things that I've
yeah,
used in my practice previously to guide me, I'd put
yeah,
into the notes. And now I've got to go out and work with it. Well, I don't have to, my apologies. I'm choosing AI because of its efficiency,
yeah,
but it
yeah,
doesn't necessarily hold all the elements that have been useful for me. And so
yeah,
am I degrading some of my practice, or how do I bring in some of that practice? And the moment we get something easy, we want to adopt the whole damn thing rather than saying, no, no, I'll do my bit
mhm,
and do. So we can see this human behavior change, and I can see it's going to take time for us to learn how to be clinicians with
yeah,
alongside AI, or that
absolutely.
AI is actually alongside us rather than we're
Yeah,
alongside it.
yeah,
And maybe a
precisely.
different synergy
Yeah,
in the future, but
yeah,
it's fascinating to observe myself,
yeah,
and have to keep questioning myself about, am I providing the best quality of care? How do I measure that? But you measure it through feelings and all sorts of stuff. But at least we're looking, right? Is the
yeah,
point? Are you going out and looking? Are you being mindful? Is there a handbrake somewhere to continue to do self-reflection?
yeah, exactly. I mean, I think as psychologists, we all know that, writing down encodes information. And so there is a lot to be said about, well, how will we, remember and reflect on these interactions when we're not the ones steering the note taking and things like that. But I think that these sorts of things, those sorts of problems and questions, they will crop up and they will, I think, hopefully become a point of that needs to be addressed. I think that's the way that AI has always operated. It brings out these weaknesses and these spots, and then we find ways to address and go around that, even if it takes a lot longer than it should. But
Yeah.
I think that's a hopeful thing.
My little shortcut has been, if I can write the brief story which lines up with the formulation,
Mhm.
that has cemented it in. But
Yeah,
I can't do that. I need to write the story in my words, so it needs to be
yeah,
relationship breakup 6 months
mhm.
ago, with a history of prior, um, imposter concerns, and so whatever it
Yeah,
might be. I need to write something brief, and then the thing that's either tipped them over the edge, or it's accumulated, or it's been,
yeah,
a number of layers. And then it's like, there's my formulation. And for whatever reason, that becomes like glue in my brain. Even
yeah,
though AI has written it and it's done it
mhm.
better than I can,
Yeah,
or at least in that time frame, but it doesn't stick like glue. So I need to
yeah.
figure out what's the glue that I can inject. But exciting stuff. Where can people find out more? How can people get involved?
Yeah.
Are there any good resources, material, websites, anything that you can kind of offer for listeners if they want to continue the conversation? How would you encourage them to do so?
Yeah, well, I would recommend the Canary website because we'll have more coming there that I think will at least provide best practice, even to clinicians like psychologists and therapists and scribes. So that's a place that I will provide a link to. Um,
Is that
and I
called
think
Canary Mission, or that's a different one? I
it's
just
actually
Googled it.
CAN, and then AIRI was a bit of a play on words. So it's Project
Ah,
Canary.
okay. Love it.
Um, so yeah, that's probably the first one. Um, but I think I will suggest from a perspective of CogSci and perhaps a more holistic, not holistic, probably a bad way of putting it, but I guess a more well-rounded perspective on AI that's not immediately from technical, so just computer science. Um, there's a phenomenal cognitive scientist called Emily Bender, Dr. Emily Bender from, I think it's University of Washington. And she has fantastic conversation around large language models and the like. And she has a podcast called Mystery AI Hype Theater 3000. It's quite a length. Mystery AI Hype Theater 3000. And so she's a linguist and she pairs up with a sociologist called Alex Hanna. And the conversations that they have about AI, although not always super, I guess they take a critical lens. I don't know. I just find it so fascinating, and it really opens you up to the socio-technical side of AI. So I'd really recommend that as a resource.
Fantastic, fantastic. And if you don't mind, just share some of those links and resources. We'll put them in the show notes so
Sure.
that listeners can go to neshnikolic.com and find them there. It's always
Yeah.
useful to find somewhere you can then continue the conversation. That podcast sounds amazing. I think I'm going to get onto that as well.
Yeah.
Lana, thank you so much for your time and insight. It's so exciting to hear about, this whole space, machine learning and, the ethics around it, the biases that come out of it, the complexities, how it's applied to radiology. The bioethics component, I think, is so important as well. So much to learn and to watch. I cannot wait to see the future. I feel like I'm in the future in actual fact.
Yeah.
Um, and trying to grasp all of this. So I'm super excited and thank you for also your expertise, energy in this space and field, because we need lots and lots of people like yourself to help
Mm.
us guide what the future looks like and how do we, as clinicians, as medical professionals, go out and apply these wonderful tools and ensuring they are wonderful. They say
Yeah.
they do what they say they're going to do. So yeah, many thanks and appreciate you so much.
No, thank you so much. This has been a very interesting and fun conversation.